So to do this linear regression on a set of data with a calculator or Excel, what we're going to try to talk about today. So here's example one in the book in section. Let's see what section is it. It's 2.4. What we need to do is get this data into our calculator, and you want to ask yourself. Uh, Typically, one's a response variable, one's the explanatory variable. So I think with this data about cricket chirping, we usually tend to make uh, you can count the chirps and get the temperature. So we're going to treat x. In fact, if we look at this graph they have, they put that chirps as the trying to predict the temperature from the number of chirps. Okay, so what we're going to do is with a graphing calculator is we're going to get that data into one of the stat lists. I'm going to quit this screen, and if you press stat and then edit, type a 1 or hit enter, you'll get your stat lists. And I want to clear these out, so I'm going to go over to the list I want to clear out and press the up arrow so that the list name is dark, and then you can just press clear and then enter. Okay, do the same thing. Clear and then enter. If you accidentally go up and hit delete, see how I no longer have an L2? To fix that, you can go back to stat, to choice 5 setup editor, and just by hitting enter, that'll set up your defaults lists. Okay, that's one way to fix that. It does other things, but that's what we'll use it for. So I'm going to put, let's see, chirps is my explanatory variable, so I'm going to put that in L1, and I'm going to put the temperature in L2, and I won't make you watch me do that. So a couple things to check on once you get your data in, that you have the same number of items in each list. If you try to do any of these calculations with a calculator, you have a dimension mismatch is what it'll give you. You need to have an X and a Y. So make sure you've got that. Okay, so now to do the regression to find the correlation, you only have to do this part once. But if you do see the catalog where it's over the 0, I'm going to do second 0, and I get this catalog. And you want to get down to diagnostics on. So you can just scroll down until you get there. It's a process. You can also use this alpha D. Press the alpha button and go to D, and you're going to do it twice for some reason. It'll jump you down to the D's. And then let's see, we want to do diagnostics on. You only have to do this once until your calculator resets. You never have to do this again. So good. So now what we're going to do is we're going to do stat, calc, and we want to do a lin regression. There's two linear regressions. One is the algebra way of writing it, and then I think it's 8, is it? Right. This is where they switch. They put the y-intercept first. It's a statistician thing. I don't know why. I'll use either, depending. I'll typically use choice 4. Okay. And on this version of this calculator, it'll prompt you for where do you get your lists. And I've got my X list in L1 and my Y list in L2. And then the residuals, and the residual list is calculating the residuals as part of the process of calculating the correlation coefficient. We don't need to worry about that. We let the calculator do that. So I'm going to have it calculate, and what I'm seeing is my linear equation. I'm seeing it's y equals, or I can say temperature equals 1.14x plus 30.28, and it's telling me the correlation is 0.95, really high. And r squared is just another calculation we can do that explains the strength of the relationship. It's the percent of variation on the temperature that is explained by the change in the number of chirps. It's statistical mumbo jumbo as far as right now. Okay, so but that's what we needed to calculate. Pretty easy. You don't have to use a fancy formula. Okay, if you can also do this kind of thing in Excel if you don't have a graphing calculator, or even Google Docs does this. If you have a Google Doc spreadsheet, um, to do this in Excel, you're going to put your data in, and then what we do is you come to a sum cell. Here, I'm going to label this R so I know what it means, and just do equals and start typing the word correlate, and you see that it gives you the pop-up, and it tells you what's your first array, what's your second array. Typically, they like to do Y first and then X. It doesn't really matter for the correlation. So I'm going to highlight that set of cells. I'm going to put a comma, highlight that set of cells, and notice I get the same correlation that I got with my calculator, isn't it? Let's see, let's make sure. This is telling me 90.5. I wonder if I type the numbers in right. That's the first thing I always check if I get a disagreement, that I didn't have a data entry problem. I could have made an entry in my calculator error too. Okay, but it's that easy, and that's how you calculate correlation. You can even on the in Excel, you can have it find the regression equation too, and you can just write equals slope. Now here it is important to make sure you pick, see the way that the dialog box telling you to put the y's then the x's. So we know that the temperature is the y's. That's what we're trying to predict. And then put a comma, and then put the x's in, and that's the slope. And to get the y-intercept, you can do the same thing. It's the intercept equals intercept. And you want to do the same thing. What are the y's? What are the x's? Whoops. Okay, and that's what the spreadsheet's given me. How does that compare? It's a little off. One place I must have a data entry different somewhere to make it be that different. Okay, but that's what you do. If that helps.